Have you ever wondered what SSRs or solid state relays are and why they are more expensive than mechanical relays and quite often take up more room, yet we still use them? In this video we will look at the difference between the solid state relay and the mechanical relay, the limitations of the mechanical relay, the limitations of the solid state relay, and finally why we would use a solid state relay instead of the cheaper mechanical relay. A mechanical relay is typically comprised of an electromagnet, an armature, and a set of contacts. The principle is when the coil on the electromagnet is energized, the armature will be pulled towards the electromagnet, causing the armature to push on the contacts, changing their position, either turning on or off the circuit the contacts control. In this example, when de-energized, the contacts are up here, completing that circuit. When energized, pulling in. These can be made to control very large currents and are used in a lot of simple motors, control or interfacing systems. Normally, there is a level of electrical isolation between the control circuit and the switched contacts. A solid state relay uses electronics to control the power output stage to switch the output. Normally, there is only one contact switch as such. In this case, the switch is a triac. Each time the contact closes, there is wear that can't be avoided. As a result of the wear, the contacts become pitted and will eventually stop working reliably, or can even fail in a catastrophic way. Most manufacturers will rate the relay or the larger version's contactors by the number of cycles they can perform before they fail. Typically, this is in the order of 1,000 to 100,000 cycles. While the number of cycles can sound like a lot, a heating element under PID control can switch at speeds of more than once per second. Let's do the maths on a heating element under PID control averaging 1 cycle per minute, working 24 hours a day, 5 days a week. 60 minutes by 24 hours times 5 days is equal to 7,200 cycles per week. A relay rated at 100,000 cycles will last just 13.8 weeks. If you increase the switch rate, you reduce the length of time that it will last. Mechanical relays also tend to have a very narrow voltage control range. This example is 240 volts AC. You can get them in a 3 to 5 volt range, 10 to 16 volt, 20 to 32 volt, 90 to 130 volt, or 200 to 250 volt range. Larger contactors you can also get in the 400 to 420 volt range. Solid state relays comprised of an opto-isolator and a thyristor circuit. An opto-isolator consists of an LED as a light source and a phototransistor for DC circuits, or a pair of photodiodes connected one forward, one reverse bias for an AC circuit. This provides an electrical isolation between the control circuit and the output controlled circuit. A thyristor is a solid-state semiconductor device with 4 layers of alternating P-type and N-type materials. It acts exclusively as a bistable switch, conducting when the gate receives a current trigger and continuing to conduct until the voltage across the device is reversed bias, or until the voltage is removed. Remember, with an AC circuit, the current and voltage will pass through zero twice a cycle as the current changes direction. Being a solid state device, these devices do not suffer wear from continuous cycling on and off. There are no moving parts to wear out. However, they are voltage sensitive and will fail easily if the voltage rating or the current rating is exceeded for even a millisecond. For this reason, it is not recommended to use solid-state relays with inductive circuits as inductive circuits are known to generate spikes due to their operational nature. The other problem with solid-state relays is they tend to produce heat, which is proportional to the current flowing through them. For this reason, they are normally mounted on a heatsink. Like any electronic component, they will fail if asked to operate beyond their design operating temperature. The control voltage is much better with a solid-state relay. Typically, there are only two ranges, 3 to 32 volt DC or 80 to 250 volts AC. Solid-state relays are best used with resistive circuits such as heaters or incandescent lights, where the switch rate is high. They can be used for very small inductive loads, but solid-state relays need to be overrated to ensure maximum ratings are not exceeded. Another advantage is the very low input voltage required, meaning some microcontrollers or programmable logic controllers can drive them directly. In the industrial environment, they are normally used with large ovens and are also used in larger 3D printers, where the bed is powered from the mains. I plan to install this solid-state relay in my 3D printer along with a 1300 watt 220 volt heating bed to reduce the heat time. To see video of that, click on subscribe and don't forget to ring the bell. If you enjoyed this video, also click on the like button so that others know it's a good video. And I'll see you on the next video.